Welcome to Computer and Network Security. Today we are going to talk about obfuscation. So to start off, we just need to look at what obfuscation is. And obfuscation, just to define it, is to confuse, bewilder, or stupefy, to make obscure or unclear, to obfuscate a problem with extraneous information, or to darken. So where this is going to come into play is whether or not we are going to be able to hide information by obfuscating it, or whether it's going to be harder for us to find information if something is obfuscated. Types of obfuscation that we have: image encryption, malware injection. Software can be obfuscated. This is often done so that it makes it a lot harder to reverse engineer, that even if you do, the code that you get back is not going to be very easy to understand. Transferring data, we might want to obfuscate it there, and in an integrated circuit, which I'll show you an example of that in a little bit today. So let's take a look here at the image obfuscation. In the parrot picture that you see there on the left, each pixel is made up of 3 bytes. That's typical for how it works. It's 24 bits. So if we just go through and change the least significant bit of each pixel in the red, green, and blue, so the RGB, because we have 8 bits for each pixel, and if we change just the last bit of each one of those, that's going to be 3 bits per pixel. That's going to be 1,000 pixels times 3 is going to give us 3,000 bits that we can actually hide. And the color is only going to have changed by a value of 1. So if your blue was at 0, it's going to be now at a 1. But each one of those colors goes up to 255. So changing it by a single value is not going to be significant enough for us to see what the difference is going to be with the naked eye. However, a program obviously is going to be able to, because you can get the raw RGB values back out of it, and then you can maybe make sense of it. This is how you can have some pictures that can have entire stories or songs or plays that are actually in them, embedded, obfuscated into the image. Okay, take a look at this picture here. The reason that I throw this one in here is because it's interesting that there are the 2 different images that your eyes can just play a trick on you. And there's actually 2 different ways that you can look at this. One way is you can look at this as an old lady that is just walking through the park, and the other one is that there's a picture of a face in the background, so you can see the eyes. I don't know if you can tell that. So here's an eye, and here's an eye. This is kind of the nose area here. So there are 2 different pictures, just your eyes kind of playing a trick on you. And this is one way that we can also embed into our image. There's an entire area called steganography. So you can take a look at that, look that word up. One of the papers for today's lecture talks about steganography, and that's where we can embed information into images. But I threw this one in there just because having an image where there's actually more than one meaning behind it is the idea behind steganography. Many viruses and Trojans that we have discussed also fall into this category of obfuscation, because they can just attach themselves to another program, and you don't even realize that code or that program has been obfuscated, because you don't understand that, all that's going on inside of it without actually looking through the source code. And even if you look through it, you're not going to realize it because the code has been obfuscated. And I'll show you an example of that in a little bit as well. So there's just some statistics on this slide. According to FBI Internet Crime Complaint Center, businesses and consumers lost $559 million in 2009, up from $265 in 2008. That's almost double, or actually more than double what was lost in that year. And you see the number of complaints are in the hundreds of thousands. And here's the categories for it: non-delivery, non-payment of goods, identity theft, credit card fraud, auction fraud, and vandalism of computers and property. The number of viruses, we've already talked about this in some previous slides, or in some previous lectures, so here's just some statistics for you on that. Okay, so take a look at this program on this slide. This is a really interesting slide. um, assume that a software vendor wants to sell its products without giving away internal knowledge of how the code works. So the software should provide the intended functionality yet hide the internal implementation completely. This is the whole idea behind object-oriented programming. Typically, you're okay exposing the interface, but you don't want to expose the implementation of it. Even looking at this code here, this is going to be very difficult to understand. You would be able to sift through it, separate it, put the new line characters and change the white space so that you would be able to read it. However, looking at it a little bit closer, there's a lot of data in there which is obfuscated. A lot of it might not even be necessary. And so I see, looking right here on the wing, M equals K times W, H equals K times T, O plus equals D times underscore times F divided by, and so on. You can see that this is not something which is very easy to understand. It would take a long time for us to understand exactly what's going on in this program, and that's even after we have to change the white spacing so that we're not looking at an airplane as we're trying to read through this code. So very interesting for how this is one form of obfuscation, and with obfuscating there's oftentimes a lot of extraneous information that is not necessary to understand what is going on in the code. There are hardware obfuscators as well as software obfuscators, and this is even difficult for the original programmers to understand what's going on. So the obfuscation usually occurs as the very last step after the programmer has finished writing the code. Then they're going to run it through a code obfuscator so that it's going to generate something that looks like this, and then they'll compile it, because even if you're able to reverse engineer the compiled code, what are you going to get back? You're going to get back something that still doesn't make much sense. So that's one of the reasons why obfuscating is used. So take a look here. This is just a real simple example. The original code, we're just going to echo hello. It goes through some different transformations, however many transformations that you want, and then on the other side you get your transformed source code. You can see the source code that was transformed on this slide is very simple to understand, but you see that it did obfuscate it slightly, made it a little more difficult to understand. One of the reasons that we want to obfuscate, though, is because software piracy alone accounts for tens of billions of dollars annually that are lost to the software industry. So we try to limit this as much as possible. Some of you may go out to be programmers, so this might actually hit home a little bit that you don't want people pirating your code. So you might want to look into some obfuscators to help that, where it makes it a little bit more difficult to do. So what's really interesting about obfuscation is that obfuscation is actually modifying the code. So it modifies it, but the result based on the input and the output is still the same. Think of it like a black box, where you don't know exactly how it's occurring. However, it's still the same regardless of what rules have changed. And so even in this case, a brute force attack is going to be very difficult to uncover, because how do you know if you have uncovered the obfuscated code? Because the code that's underneath it is obfuscated. So as you are trying to reverse engineer, what you're getting back is something that you may not think is the actual code, because that has been obfuscated. So it makes it very difficult to reverse engineer obfuscated code. Okay, so let's take a look here at an integrated circuit. So due to globalization of integrated circuit design flow, rogue elements in the supply chain can pirate the integrated circuits, overbuild them, and insert even hardware trojans. Companies often will obfuscate the design by randomly inserting additional gates where only a correct key makes the design produce correct outputs, and I'll show you in just a second how that works. In untrusted design phases, the IC is obfuscated and its functionality is not revealed. After it's fabricated, the IP vendor activates the obfuscated design by applying a valid key. The keys are stored in some kind of a tamper detect block memory inside the design to prevent access to an attacker, rendering the key inputs inaccessible. So you can see that is this right down here. This detect block makes it where it's difficult to know exactly what those are. So let's look at some logic obfuscation here. Just with some, what do we have here? Some NAND gates, some NOR gates, and then some exclusive OR and exclusive NOR gates. So only in this case when the proper key gates, so K1 and K2 are known as the key gates. Only when the proper key gates are activated will the circuit act properly. So if the wrong key is provided for these values over here of K1 and K2, then you're not going to get the right output. So see, these two gates here have been inserted into the design. Instead of connecting G5 straight to G7 and G3 straight to G6, these have been inserted in the middle. And then to activate those gates, meaning that they're going to let this signal from G3 and this signal from G5 go through, are going to take specific values for K1 and K2. This one seems like it would be very easy to crack because there's only two gates there, and you could probably write a program that could crack that. But what about here now? If we add a little bit more smart logic into it, where these gates actually are dependent to get the data through, and it's also dependent on the data which is coming through. So now these gates have been added in here to the middle, so that instead of this connecting straight to G4 and this one up here connecting straight to G4, they have to go through these middle gates. And now activating K1 and K2, these are going to make it much more difficult to figure out what they are. It's going to take a brute force method. However, even with a brute force method, you're going to have to know what output you're expecting based on the input. So you're going to have to know something about the circuit before you start even doing some brute force. So interesting designs. Let me show you now a JavaScript obfuscator. So you can take a look at this site, javascriptobfuscator.com, and you can type in some JavaScript code up here at the top, and then you can click the obfuscate button, and you'll see what comes out down here at the bottom. So it obfuscates it for us, and you can see just by looking at this code down here that if this is what you were actually looking at, you would have no idea what that is actually doing. That code actually is the same, and if you look at the top code and compare it to the bottom, you can kind of see what's going on. So here's a message box function, which is going to be this one right here. And you see what it's passing in. Oops. That's going to make it even harder if I start moving things around. So what it's passing in here is that underscore 0xefdd sub 2. Well, the underscore 0xefdd is the name of this variable, which is an array. And the element, which is at the index 2, which is the third element, is right here. This /x in front means that we're going to be dealing with hexadecimal values, I believe. And then you see it's going to say 4f, and then this one says 4b. Well, I can go ahead and guess that 4f is probably O, and 4b is probably K. So those are going to be the hexadecimal values of those two characters. And so you can see that this line right here, coupled with the top one, is going to be this message box OK. And then here's the alert in the middle. So here's the alert, and you can see what it's doing though is the 0x562EX3 followed by appended with this OXEFDD sub 1 followed by the letter A of that variable A, which is right there. So oh, there it is. This one here, the 0x562EX3 was the variable that was passed into that function. This is the variable, the parameter right here. The 0A, I'm going to guess that's a new line character, and then followed by the variable A, which was declared right here as the 0xefdd sub 0, which is this first part right here. And you can go ahead and guess that that probably says hello world in hexadecimal. So you can see if you're really piecing this back together. But see, we were able to figure this out somewhat quickly. I mean, it still took a few minutes to do it. Well, that's because we knew what the original code was that we were obfuscating. And this is a very, very simple program. You can only imagine if this was a much longer program, how long it would take to figure out to go backwards from an obfuscated code to this. And this is a very simple obfuscation here also. There are much more complicated obfuscations that occur. So hopefully that gives you a nice little introduction to what obfuscation is and how it works, and where it is used, how it applies to computer and network security. If you have any questions, let me know. Good luck.